So here we are considering the third problem of Newton-Raphson method. So the function given over here is x into sin x plus cos x. Now they have said few things in this question. To find the root of this function to 3 decimal places. Which is near x equal to 5. Now what's the meaning of here? That the initial approximation is given in the question itself. No need to find the negative, positive, where it lies, where the root lies and all. Just you have to consider x naught as what? 5. So as we know that we have to find f dash of x also. Here these two are a function of x. So we have to apply the product rule to find the differentiation. F dash of x means differentiation with respect to x. So UV rule, I hope you know that UV rule basically means product rule. First into differentiation of second plus second as it is into differentiation of first. So first function I will consider x. X differentiation of sin x will be cos x plus sin x as it is into differentiation of x is 1. Okay, plus then cos x differentiation is minus sin x. So we can say that these two get cancelled, right? So what is left out? X cos x. So f dash of x is equal to x into cos x. So this part is done. Now we'll go for the formula. So x naught we are considering it as what? Pi. It is already given in the question. The formula for Newton-Raphson method is xn plus 1 is equal to xn minus f of xn divided by f dash of xn. Now here first iteration is n is equal to 0. In place of n you have to substitute 0. So it will be x1 equal to x0 x naught minus f of x naught divided by f dash of x naught. Okay, that means we have taken x naught initial approximation as pi. So pi minus f of pi divided by f dash of pi. This is what we are getting, correct? So pi minus f of pi means what? In the function itself we have to put pi. Remember, put in the radian mode. Okay, r mode. Now here what we'll be getting? F of pi. So x into sin x plus cos x, if you substitute pi, sin pi value is 0. So cos pi is minus 1, you'll be getting minus 1 divided by then f dash of pi, then x into cos pi is minus minus 1, so it will be minus pi. Minus minus cancel, you'll be getting the value as how much? Pi minus this thing 2.8232. Okay, I hope you understood. Just you have to substitute in the value. Okay. Next, the second iteration will go for n is equal to 1. So what happens? x2 is equal to x1 minus f of x1 divided by f dash of x1. Again the same thing. x1 has now changed. It is 2.8232 minus f of 2.8232 divided by f dash of same thing. So in place of x you have to substitute 2.8232 in the both the function f of x as well as f dash of x. So you will be getting x2 value as 2.8232 minus the what is this f of this value? It is I am getting minus 0.0659 divided by minus 2.6813. So if you solve this one, you will be getting the answer as 2.7985. Okay, next, now this particular value and this particular value, there is a slight difference, error is there. We'll try to decrease the error, so we'll go for this third iteration as well. So this n is equal to 2, it will be x3 equal to x2 minus f of x2 divided by f dash of x2. So it will be 2.7985 minus f of 2.7985 divided by f dash of 2.7985. Okay, now if we substitute this, x3 becomes 2.798. So we are getting this value. Now the thing is that this particular value and this particular value, there is a minute error only. that means only decimal error. So we can finalize the answer. Okay, so this particular value I didn't write, just I'll write it out here. So this I'm getting it as minus 0.0003, and this particular value I'm getting it as minus 2.6354. Okay, now the root of the equation becomes, here we are stopping the iteration because this previous iteration value and this iteration value is almost same, error is minute, that's why the root of the equation becomes 2.798. This is the final answer. Okay, up to 3 decimal places, final answer.